Hello everyone, and welcome to today's presentation. I'm excited to introduce you to our topic, Introduction to Live Data. On this slide, you'll see the title and subtitle, which highlight the focus of our discussion. Over the next few minutes, we'll explore what live data is, how it fits into Android Jetpack, and why it's such a useful tool for managing data in your apps. We'll also cover its lifecycle awareness and how it helps prevent common issues like memory leaks and crashes. So, let's dive in and discover the power of live data together. Let's talk about why using live data in Android is such a good idea. First, lifecycle management is a huge benefit. Live data automatically handles the lifecycle of UI components, which helps us avoid memory leaks and crashes that can happen if we forget to clean up observers. It's like having a smart assistant that knows when your activity or fragment is active and when it's not. Next, active UI updates are critical. Live data ensures that updates to the user interface only occur when the app components are actually active and in the foreground. This prevents us from trying to update a UI that isn't visible, saving us from unnecessary errors or wasted resources. Moving on to simplified communication, live data makes it easier for our UI components to stay in sync with the data. Instead of manually updating views or managing complex callbacks, we can observe data changes directly, which keeps our code cleaner and more manageable. Finally, live data embodies reactive programming. This means our UI can react automatically to data changes in real time. It creates a more dynamic and responsive user experience, which is at the core of modern app development. When we integrate live data, we're making our apps more robust, efficient, and easier to maintain. Let's start by exploring the core live data concepts. Live data is an immutable observable data holder, which means it holds data that can be observed for changes, but you cannot change it directly from outside. It's designed to be observed by UI components like activities and fragments, keeping the UI in sync with data updates seamlessly. Now, mutable live data is a subclass of live data, and this is where the key difference comes in. With mutable live data, you can actually update the data it holds, using methods like setValue for main thread updates or postValue for background thread updates. This flexibility makes it very useful for managing data that changes over time. Next, we have the concept of lifecycle owner. This is typically an activity or a fragment that owns the lifecycle of the live data observation. It's crucial because it ensures that the UI only observes live data when it's in an active state, preventing memory leaks or crashes from updates when the UI is not visible. Connecting this all back to our overall theme, understanding these core concepts helps us build reactive, lifecycle-aware apps that are robust and efficient. Live data and mutable live data form the backbone of this approach, while lifecycle owner ensures our data updates are handled safely and appropriately within the app's lifecycle. All right, so now that we've covered the basics, let's talk about adding dependencies to your project. What I want you to do is open your build, Gradle file at the app level. Inside, you'll see a dependencies block, and that's where we add the necessary libraries. Specifically, you'll include 3 lines. The first one is for Lifecycle Live Data KTX, the second for Lifecycle ViewModel KTX, and the third for Lifecycle Runtime KTX. All of these are version 2.8.7, which is current as of now. Now, why are these important? Well, these dependencies provide Kotlin extensions that make working with live data and ViewModel much easier and more streamlined. They help reduce boilerplate code and make your code more idiomatic to Kotlin. Connecting this to our overall theme, adding these dependencies is a crucial step in modern Android development because it enables us to leverage the latest lifecycle-aware components efficiently. Once you include these, you'll be ready to implement robust, reactive data handling in your app. Let's take a closer look at how we define live data in a ViewModel. In this example, we have a class called myViewModel that extends ViewModel. Inside, we declare a private mutable live data object called count. This private property allows us to modify the data within the ViewModel itself, ensuring that the data can be changed only internally. Then, we expose a public live data named count, which simply returns the count object. This way, the UI can observe the count, but it cannot modify it directly. This pattern, using mutable live data privately and exposing live data publicly, is really important. It helps us maintain a clear separation of concerns. The view model manages and updates the data, while the UI observes changes without the risk of accidentally changing the data. Finally, notice the increment counter function. It reads the current value of count, defaults to 0 if null, and then updates the value by adding 1. This encapsulation ensures that data changes happen through controlled methods, further promoting a clean architecture. Connecting this to our overall theme, it's all about creating a robust, predictable data flow where the UI reacts to data changes safely and efficiently. Now, let's talk about observing live data in an activity. In this example, you see a main activity class that extends app.compat activity. Inside the onCreate method, after setting up the layout, we initialize the view model using viewModelProvider. Then, we call observe on the live data object called count. We pass this as the lifecycle owner, which is crucial. It ensures that the observer is only active when the activity is in a suitable state, like started or resumed. The Lambda function inside observe receives updates to the data, and in this case, it updates the text view with the new count value. The key point here is that the observer only reacts when the activity is active, thanks to passing this as the lifecycle owner. This pattern helps us avoid memory leaks and unnecessary updates when the activity isn't visible. Overall, observing live data in this way makes our UI more responsive and lifecycle aware, aligning perfectly with the broader goal of building robust, reactive apps. All right, let's talk about updating live data. When you're working on the main thread, you want to use setValue to update your live data synchronously. This means you assign a new value directly, like count value equals new value, and it updates immediately. It's straightforward and works well when you're already on the main thread. But what if you're updating from a background thread? In that case, you should use postValue. This method allows you to update live data asynchronously, which is crucial because you can't directly modify UI-related data from background threads. So you do something like count, postValue, new value. This way, the change is safely posted to the main thread, ensuring your app remains responsive and thread-safe. Remember, understanding when to use setValue versus postValue is key to managing live data updates effectively, especially as it ties into the overall theme of keeping your app's data reactive and synchronized across threads. Now, let's talk about live data transformations. First, we have Transformation Map. This is a really useful tool when you want to convert your live data into a different type. For example, if you have a live data object holding a username, and you want to get the length of that username, you can use Transformation Map. It takes your original live data and applies a function, in this case, getting the length of the string, and returns a new live data that reflects that transformation. This approach keeps your data reactive and clean, making it easy to update your UI based on these transformed data streams. Next, we have Transformation Switch Map. This one is a bit more dynamic. It allows you to switch to a new live data source based on the value of your input live data. Imagine you have a live data that represents a user ID, and depending on that ID, you want to load different user data. Using Switch Map, you can observe the user ID, and whenever it changes, automatically switch to the corresponding live data source for that user. This is especially powerful when dealing with dependent data sources, because it simplifies observing changes and ensures your UI always reflects the latest data. Both these transformations are key tools in making your live data reactive and adaptable, tying perfectly into our overall goal of building responsive, clean, and maintainable apps. So let's talk about Mediator Live Data. Essentially, it allows us to observe multiple live data sources at once. When any of those sources change, Mediator Live Data reacts accordingly. For example, we can set it up to listen to two different live data objects, and whenever either one updates, Mediator Live Data will update its own value. This makes it really powerful for combining or coordinating data streams. Now, moving on to handling lifecycle changes, like configuration changes, such as when the device rotates. Livedata has a built-in advantage here. It automatically keeps track of the latest data it has received and ensures that any new observers, like after a screen rotation, get that latest data immediately. This means we don't have to worry about refetching data every time the configuration changes, which simplifies our code and improves user experience. Overall, these features, Mediator Livedata's ability to observe multiple sources, and Livedata's automatic data delivery after lifecycle events, help us build more resilient and responsive apps that smoothly handle user interactions and device changes. Let's talk about some best practices and tips to make the most of Livedata in your projects. First, immutability is key. Always expose immutable Livedata from your view model to prevent your UI from inadvertently modifying data. This helps maintain a clear flow of data and avoids bugs. Next, focus on UI state only. Use Livedata specifically for communicating UI-related state changes, so your data layer remains clean and focused on business logic. When it comes to performance, be cautious. Avoid long-running or blocking calls inside setValue or postValue, as they can hang your UI or cause sluggishness. Instead, handle such tasks asynchronously. Memory management is also crucial. Use lifecycle owner-aware observation to ensure your observers are active only when needed, preventing memory leaks. Lastly, remember that combining Livedata with view model creates a robust MVVM architecture. This separation of concerns leads to more maintainable and testable code. Keeping these tips in mind helps you build reliable, efficient, and clean Android applications.